Hello everyone, welcome to part 2 of this review of rational exponents and radicals. This page has to do with some graphing, and assuming it doesn't take that long, we might be able to get to the second page as well, which has to do with inverses. I think we can do it. Woo! So number 7, it says f of x is equal to the negative 3 times the cube root of x plus 2 minus 1. So this is in vertex form, and in fact, all of these are in vertex form. In vertex form looks something like this, and I literally mean it something like this, where you have something in here, and then you have something out here. There's usually an x, in this case it's a 2x, but in this case it's an x, and then you have some number here, and then some number out here, and then there's usually some number here. In this case, it's a square root over it. In some cases, it's squared. In some cases, it's to the third power. In some cases, it's absolute values. But there's always something in front, something with x, and something in back. And this is called HK form, where h is the number next to x, and k is the number that is in back. Notice that it does say x minus h, which does mean that whenever you find out where the vertex is, or the special point is, you do have to flip its sign. So like if this is an x minus 3, you would have to make this a positive 3. If this was an x plus 3, then you would have to make this a minus 3. So you have to switch the sign of that one, but you know, if this was just 7, then you put 7, something like that. You don't switch the last number. So going over here, you can see x plus 2, which means my special point would be at negative 2, comma, negative 1. Because you switch that one, but not that one. The formal reasoning behind it is that you're setting this part equal to 0. So like if x plus 2 equals 0, you would get x equals negative 2, which is why that comes about. So I just wanted to mention that. Whatever makes that 0 goes there. So negative 2, negative 1, I'm just going to go plot that. Next thing is this negative 3. What that negative 3 is basically it's going to flip it upside down because of this negative sign, and this 3 is going to make a vertical stretch. Now I'm going to do something, I'm going to use a word that's non-mathematical, and that is slope. Usually in a line, the number in front is called the slope, and that's kind of true here. This 3 does say you could go down 3 and over 1, and up 3 and backwards 1. Like that. And these are 2 points that this graph is going to go towards. Just know that you cannot like do it again, because then you would start actually drawing a line, and this is not actually a line. This is a cube root function. And what cube root functions look like is this. It goes kind of like over, up, over-ish kind of thing. But as I said, this one got flipped upside down, so this part's actually up here. This part's actually down there, and it's going to look more like that. As you can kind of see, it's going to go like, boom, like that. Okay, so this is the answer right here. It goes through the point, negative 2, negative 1, and you can use that negative 3 to go down 3 and over 1 or up 3 and over 1. And you only need 3 points here. Domain, arrow to the left, arrow to the right, so it's all real numbers. So you can write negative infinity to infinity or all real numbers, whichever. And range, it does go down arrow and up arrow, so it's the same thing. All real numbers, or you can write negative infinity, infinity. Okay. So this one is a square root graph. Square root graphs look like this. So just write that as a note. Square root looks like this, where this is the special point, HK. And this time, you kind of have to go back to what I was saying over here, where it's what makes this 0, because believe it or not, the vertex is not going to be at 6. It's actually going to be at 3, because if you set this part equal to 0, you would get x equals 3 for what makes it 0. So this one is going to be at 3, comma 3. 1, 2, 3, 1, 2, 3, like that. Okay. This is going to go downwards because of that, like here. And I'll be honest, the easiest way to do this one is probably just in a calculator to double check your points. I'll show you how to do that. So let me go get a calculator. So if you go to y equals, type in negative sign, and then square root 2x minus 6. Then you go outside and do plus 3. You can kind of see it's going to be this u going down right over there. And we should be able to see a point if you go to the table. You see a bunch of errors. That's because, it does stop going to the left. So 3, 3, that's the point we did already. And then it looks like there's a point at 5, 1. So I'll go ahead and plot at 5, 1. 1, 2, 3, 4, 5, 1. Like that. And I'll just scroll, see if there's any others. 11, 1. 11, 1, I'm pretty sure is off the charts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe not. Okay. So I'll go there and make another point. And there's my graph. Boop. Okay. I recommend using the calculator if there's some number in front there. It's just a little bit easier, a little bit safer. Because as you might notice, it doesn't actually go down 1 over 1 in this case. It only works if there's no number in front of the x. But as you can see, usually there is not a number in front of the x. All right, so this next one. Just ignoring this part, the vertex. See if you can think about where the vertex is going to be. It'll be at positive 1, positive 3. Cube root. What does cube root look like? What is the parent graph, as they call it? Looks like this. Since there is a 2 in front, that means it's going to be like up 2 and over 1, down 2 and over 1. There's no negative sign, so it's not going to flip upside down. So 1, 3, there's a 2 in front, so I'll go 1, 2 over 1, down 2, backwards 1, and just go like this. And domain range is the same thing as before, and I'm only just now reasoning that I never did the domain and range here. So let's go back to that. Domain, the farthest left it gets is right here. So the farthest left it gets is positive 3, including the 3. So there's a bracket. And then going to the right, it's an arrow, so that'll be infinity. As for the range, the lowest it gets is negative infinity because of the arrow. And the highest it gets is right here, which is at positive 3. Once again, including the positive 3. When you have square roots, it's always going to look like this, one number with a bracket. If it's cube root, it's always going to be both infinities because of the arrows. Okay, so here we go. This one, vertex is going to be at, since that's a minus, a plus. So that's a plus, a plus. So 2, 1. And, just trying to teach you guys to be careful. Let's go with 1/2 square root x minus 2 plus 1. Can never hurt to check in a calculator. So there's the 2, 1 point, and then it goes up like that. So we'll go to the table. If you guys are using Desmos, then you can just kind of scan around the graph to click on something that works. But looks like 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. That's good enough for me. Woo! So domain, the furthest left is 2. The furthest right is infinity. For range, the furthest down is 1, and the furthest up is infinity. And there you go. So that's it for this page. Once again, it's important to know that if you have a square root, the graph will be a point going like that. And if you have a cube root, it's going to be going like that in both directions. Okay, so that took a little longer than I thought, but whatever. It's all good. I guess I'll see you on the next page with inverses. Peace.